The science of welding, electromagnetics. Fun fact, if you've got a current passing through a material, you've got an associated magnetic field perpendicular to it. This is due to the physics involved, electronic and the magnetics, the forces exerted upon each other when they're moving, but just for the purposes of this little discussion, recognize that anytime you've got electricity going from point A to point B, you've got magnetism. And you've seen this in your shop if you've got metal shavings of any kind and they've landed on the floor where your cords are. See? And you can even see how the little steel ferrous shards are lining up perpendicular to where the cord is. And we can put this to good use in welding with non-destructive testing. Say you want to test out a part, you want to know if there are cracks in it, but you don't have the money to x-ray a whole bunch of parts. You could do a liquid penetrant, but that leaves residue and it's a little bit time consuming. You can use these magnetic fields through a conductive material to see where the cracks are, and it's really cool. It's been a while since I learned this, but I think every time we use the right-hand rule, which means that if the current is traveling this way in the conductor, this is the direction that the magnetism is going in. And you can magnetize a part either longitudinally or around its circumference. Let's just say that this is a part that I had welded and then buffed off, maybe machined, and we want to know if there are any cracks in it. This is a poor example, but it's the right shape. Cracks and defects could run longitudinally in it, right? Or they could run this way, or a combination of anything. Magnetic particle testing has to do with introducing a solution filled with itty-bitty ferromagnetic particles, like iron shavings in it, over this, as a current is being passed through it. Magnetic field is induced into the part by passing a current through it, and the magnetic field is always at a right angle to the direction of the current flow. And when there's an abrupt change anywhere, either circumferentially or longitudinally, it'll show up, it'll register, often by fluorescing, because that carrier water or oil that you have the suspended particles in fluoresces under UV light. And so if you've got dark light and you do the current thing and you do the wash thing, you can see your cracks glow if they're surface or just under the surface. So if you want to determine any cracks that are going circumferentially, you would put a yoke over it and magnetize. Oh, I get so confused. Pass a current circumferentially around the part, which would then magnetize it longitudinally, meaning that you would see any cracks that are running circumferentially. Oh, this was hard to remember. As it bumps into that crack, there's an interruption in the magnetic field, and that's where the iron particles stick up. Holy cow, I hope I got all that right. Basically, any crack that is in the middle of that magnetic field creates two new poles that can adhere any itty-bitty metal particles. I thought this video was going to be easier to make. I thought I had a grasp of this concept. There is another time that current affects magnetism when you're welding, and that's when you encounter arc blow. Real term. Oh, I wish I could animate. If you can imagine, as this is plugged in and carrying a current, is carrying it straight through the material, but if there is a kink in the line, you still have the current being carried, but what about those magnetic fields? They are now compressed on this side and kind of stretched out on this side. Imagine your welding table as being that table, and you've got your hot stinger and your ground. Electricity is going from point A to point B all day long, creating these fields of flux, these magnetic fields. And it's not in a perfectly straight line, and that affects your arc, and it kind of makes it dance around and do this goofy wiggle thing like you can't control it anymore. I've heard it described as dancing as a thread in the wind. And it comes from the buildup of these magnetic fields, these flux fields, as you're welding all day long. Or if you're in school, there were people welding before you and then people welding after you, or first, second, and third shift. And it can be minimized by switching your ground clamp around and kind of like moving things, or welding on alternating current, because that's switching the magnetic fields back and forth. I actually apologize for this video. Thank you for coming to my weld talk. Oh my